3D design for 3D printing bonus tutorial. You asked for it, a complex part, step by step from start to finish. This video is part of a series on learning 3D design for making custom 3D printed parts using a free Onshape account. Everything from this video has been covered earlier in the playlist, and that playlist is linked in the description. As per your requests, today we designed a complex part from start to finish. It has extrudes, revolves, lofts and sweeps, plus more. So let's build it one step at a time. This is my brother-in-law Matt's old motorsports helmet, and on the top we have a duct used for moving air. His new helmet also has a duct, but as you can see, the port is different. So what we need to do is redesign the transparent part, but with the correct outlet to suit the hose that's already in the car. The original part is quite complicated. As you can see, it's curved from the side as well as left to right. And as well as the overall curvature, there's lots of little details to model too. Therefore, I needed to take an exhaustive set of measurements, and to do that, I primarily used digital calipers. If you don't own any, I have a link to an inexpensive set in the description. Of course, I also needed to take the measurements of the duct on the old helmet. Again, calipers was the best tool for most of this. One other tool that was invaluable was this printed fillet gauge, which is linked in the description. You use it to determine the radius of fillets by placing it on the part. All of my measurements were placed on a series of diagrams which I will be using as reference. Once again, I'm adding to the TT tutorials document, which is linked in the description. I'm going to come down to the lower left, create a new part studio, and then I'm going to right click on that tab and rename it. We're going to start by modeling this mounting foot, and we're going to start that by sketching this front profile. The first thing I'm going to do is create a sketch on the front plane, pressing P to hide the planes and then N to spin the camera. This sketch will be turned into a sweep, and I like to start most of my sketches with a center construction line. I'm going to start by using the arc tool and drawing a lower and upper arc, followed by the concentric constraint to make them share the same center point. I can now draw a pair of straight lines, snapping to the ends of the two arcs to complete the profile. Finally, a horizontal construction line. Time for some dimensions, and I know the thickness of the plastic is 2 mm, and the overall width at the front is 49 mm. Finally, I measured from the underside of the arc to the flat point 1.7 mm, so I can input that now. As you can see, everything is black and we're ready to proceed. The plan is to use a sweep to extend the shape backwards on a curve. So now we need to draw that curve, and that means starting a sketch and drawing from the right hand side. We'll press N to spin the camera. The first thing I'll draw is a horizontal construction line, and then I'm going to come back and draw a 3-point arc from the same point and align it with the right hand side of that construction line. A tangent constraint has automatically been applied here, which is what I was after. Let's add some dimensions, and I know the width from front to back is 87.6, and this was hard to measure, but I'm pretty sure the drop was 20 mm. Again, everything is black and fully constrained, and that means that I can close the sketch. We have the two sketches we need in place for a sweep, so we'll come up to the sweep tool, we'll select the middle of our profile, and then we'll switch to sweep path and click our arc. And as we hoped for, we have our sweep that makes up the basis for this duct. When using the fillet gauge, I measured that the corners of this piece have a radius of 5 mm. So now I can select the fillet tool, select the 4 corners, and then input a radius of 5 mm to match. And with that, the base is near complete. Next, we're going to model this main body section by using a loft. This section sits inwards from the mounting lip, so to accommodate that, we're going to draw a plane. I'm going to offset it from the front of the object. So I'll click on the front surface and then enter my measured value, which is 5.6 mm. Fix the direction and we're ready. Let's start a sketch and select this plane, and we're going to press N to spin the camera. I'm going to start by pressing U for the use tool, and you can think of that as tracing. So anything you click, that geometry will be translated to the current sketch. With this lower arc traced into place, I can now draw a center construction line, and that will help me have a symmetrical sketch. From here, I can draw a series of straight lines to build up the rest of the sketch. After drawing the right hand line, I then come up to the mirror tool, click on my center construction line, and then click on the border to copy it to the other side. Finally, a line completes the shape. All I need to finish this sketch are some dimensions. I'll start with the overall width, which I've measured as 37, and the height was very tricky to get with the calipers, but I'm going to start with a value of 32 millimeters. That's another sketch finished and the first half of what we need for the loft, so let's close it and move on. For the second profile that's going to make up the loft, we actually need it down on this strange angle at the back. We're going to create a custom plane, and to help us get that accurate, we're going to start a sketch from the right hand side. I need some reference geometry, so I'm going to press U for use and trace this little straight line, and then I'm going to draw a second line perpendicular to this, and this is the crucial line when it comes to generating our plane. Time to use some more constraints to get everything perfect. A coincident constraint will get the two lines touching, followed by a perpendicular constraint to get them at 90 degrees. There's not much to this sketch, but it's actually everything we need to continue. We can now create a new plane, and we're going to change the type from offset to one that I'm not familiar with, and that's called line angle. We'll now click the line that we drew in our previous sketch. Despite this warning in blue at the top, we can actually ignore it and hit the tick. If we click to show the plane, we can see that it's followed our line in terms of its angle, and we're ready to draw. So let's sketch on our new plane, which is plane 2, and my philosophy with lofts is to keep things as simple as possible. That means we're going to use simple geometry to match the other end of the loft. That means 3 lines with a shallow arc to go across the bottom. If we compare the two, for one end of the loft we have flat, 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 and then a shallow arc at the bottom. Therefore we have flat, 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 and the same shallow arc at the bottom. I'm going to use constraints to align both of the sketches. That way I'll know the two sketches will match in width. And to get my arc matching, I'm going to click on the old arc, observe the radius of 177 in the corner, and then dimension my new arc with exactly the same value. We can see that this is definitely not symmetrical, so let's apply an equals constraint. The way we're doing this loft, it's almost impossible to get it perfect, so I'm just going to eyeball it and drag it into position to match a real world object. If in doubt, I like to add a dimension and round it to the nearest whole value. I'm happy with this, so I'm going to close the sketch and let's move on to creating the loft. Let's open our loft tool. Clicking the first profile is very easy, but the second one is actually embedded in the middle, so we can't click it, but we can also select it from the feature tree on the left hand side. What we see at the start is a very basic loft, and obviously this is the wrong shape. The easiest way to get the required curvature is to change the start profile from none to normal to profile. The default value of 1 is probably not curvy enough, so let's increase that to 1.5 and see how that looks. In terms of fitment, this curve is non-critical. To me it looks pretty close to the original, so I'm happy with it. However, on the right hand side it looks like we might be twisted, so we're going to tick match connections, click on the field, and then click on the upper corner matching for each sketch, and already we can see things look a lot better. The loft now extends a little bit further to the back. It is concave in the middle, but that won't matter after we clean up our design. So I'm considering this loft complete, and I'm going to hit the tick to finish it. This duct actually tapers from front to back, so I'll need to match that if I expect it to fit the new helmet. The tool we're going to use to achieve this is called Draft. The first thing we need is a neutral plane, and generally that's going to be perpendicular to the surfaces that you're drafting. This flat surface on the face is ideal for this purpose. We now come to the left and click on Entities to Draft and input the faces we want to add draft or angle to. For this model, there's 4 in total that we need to click, and that's the outer flat surfaces on each side. Our part's actually getting wider instead of tapering, so let's reverse the direction, and already we see we're in the ballpark. What I'm doing at this stage is some trial and error to try and get the right angle. I've measured the real life part, and I can click the 2 outer points and compare them to what I've measured in real life. Fast forward a couple of iterations and 2.4 degrees ends up being exactly what I need, as it's within 0.5 millimeter of real life, and that should be fine. The real part of course is nowhere near this chunky, so let's apply some fillets on the upper corners, and we use the fillet gauge and measured those at 10 millimeters, so that's the value that we'll input. Also, to match the real life part, I'm going to apply a series of fillets, only 1 millimeter in radius, and my target for these is the edge of the front face, as well as the junction between the upper and lower sections. We're now going to switch our attention to the old helmet, starting with this mounting boss at the bottom. This is going to be a simple 3D extrusion, so we'll start a sketch on the front flat surface, press N to spin the camera, and then, like I like to, I'll start with a center construction line, before switching to the circle tool and drawing a circle that will represent this boss. I want the perimeter of my circle to touch the edge of the face, so I'll use a coincident constraint to lock them together. And finally, dimension the outside of the circle to 25mm. This sketch is now done. Now it's just a matter of a simple extrude, selecting our profile and extruding to what I measured, which was 7mm. Now I think is a good time to make this part hollow, and my tool of choice is the shell tool. At this stage, I only want the underside to be open, so I'm going to rotate the camera, click that surface, and I can see from the preview that I'm in the ballpark. It's hard for me to measure, but I'm pretty sure the thickness is 2mm, so I'm going to change my value to that, and given there's no errors, I'm going to click the tick to complete my shell. Just to keep things tidy, I'm going to apply a fillet on this inner edge with a radius of 1mm. The next step is to model the actual fitting that the hose goes onto. The plan here is to use the Revolve tool, so we need a basis sketch first that we're going to draw on the right hand side, and since we want something to snap to, we're going to press U for the use tool and then trace this leading edge of our boss. My aim here is to draw exactly half of the shape ready to be revolved, and although the dimensions for this one are critical, fortunately it's only made up of a series of straight lines. So like I often do, I'm just drawing the rough shape, and once that's done, I'll be in a good position to add some dimensions. These two diagonal lines should be symmetrical, so therefore I'll draw a simple construction line from the midpoint of the horizontal line, and then I'm going to apply a symmetric constraint. My first click is on the line of symmetry in the middle, and then after that I'll click the two diagonals and they'll be locked to match each other. Now if we drag a point on one side, we can see the point on the other side matches it. All we need to do now is add some dimensions to fully constrain this sketch. The total length is 26mm, and unfortunately that stuffed up our geometry, but if we're a little bit patient, we can click and drag the points of the sketch that we've drawn so far until we find the correct position. That looks much better, and now we're in a position to add our final dimensions. It's simply a matter of adding in what I measured with the calipers. But now as I add the overall radius of this profile, I have an error because my sketch is overly constrained. When I started drawing this sketch, I accidentally snapped to the midpoint. The radius of this mounting boss is 12.5, but I've dimensioned 10mm and the two conflict. The constraints that clash are highlighted in red, so I'm going to click on the midpoint constraint, press delete on the keyboard, and everything snaps into the correct position and the error is gone. My final dimension is for the radius of the widest section, which I measured at 11.4mm. That makes everything black and constrained, so we can come up to the tick and finish the sketch. We now come up to the Revolve tool, and the first thing we need to input is the profile we're revolving. After that, we click on Revolve Axis and click our center line, and our geometry will be spun around that center line, creating the shape that we want. Something obvious is missing to complete the basic shape, and that's a hole from the front to the inside. This is a simple extrusion, so I'll start a sketch on the end surface, trace the outer circle so I have a center point to snap to, and then use that to draw a circle in the center, dimensioning it to a diameter of 18.5mm. This sketch has everything it needs, so let's close it, come up to Extrude, select our sketch profile, and then select Remove, because our aim is to do a cut back into the middle section. Ending the extrusion with through all is not an option, or it will cut out the back of the duct. So to keep it accurate, I'm going to say up to face, and then I'm going to spin the camera around and select the internal face, meaning that our cut will end exactly where we need it. Before we save the extrude, the inside of this hole is actually tapered. That means it gets smaller as it goes in. To achieve that, we're going to click draft, and then we'll reverse the direction. We can see that it tapers in. Again, it's pretty much impossible for me to measure the angle, but 3 degrees looks about right. On the inside of the duct, let's add another fillet to assist with airflow. 1mm will be fine for this, just to keep things tidy. One more feature left, and it's these little prongs on the inside of the duct. Now the bottom of these prongs are actually curved to match the bottom of the mounting surface. So my plan is to draw them oversized and then cut them to match. Therefore, I need to create a new plane. I'm going to offset it from the top plane, and the exact position doesn't really matter as long as it's below the rest of the geometry. As always, we'll start a sketch on this newly created plane. We'll press N on the keyboard to spin the camera and zoom in ready to draw. I want some geometry to snap to, so I'm going to press U for use and trace one of the internal walls. And since these prongs are symmetrical, I'm going to add a center construction line that I'm going to use to mirror later on. A reminder that if you forget to make something a construction line, you can always click on it after it's been created and then press Q to toggle. Each prong is simply a rectangle, so I'll use a rectangle tool to draw them in the rough position, and then I'll immediately use the mirror tool, selecting my center line, and then clicking the perimeter of the rectangle to copy it to the other side. Now as I add my dimensions, you'll notice that both rectangles update because they have a symmetric constraint. This part of the sketch is actually quite straightforward, but what's to come is a little more involved. Everything is constrained, so let's close the sketch and then come to the extrude tool, select our two profiles, and change their end condition from the default blind to up to next. That will terminate them on the inner surface of the duct perfectly, but because we're going to cut them in half, we want them to be separate, so we're going to change the mode to new instead of add. We need a curved surface to cut these in half with, and we actually already had a line all the way back in our second sketch. So let's start an extrude, but we'll change the mode to surface, and that will allow us to click on a line rather than an enclosed profile. I'm going to set the end condition to through all, and then I'm going to tick symmetric. That way we kind of have a curved plane that goes the whole way through the model. We can tick to finish the surface extrude. Next, we're going to click on the split tool. We initially select the parts that we want to split, and that's our two prongs. We then click on entity we want to split with and select our curved surface. And if we zoom in, we can see in the preview that our prongs are now split where they will be segmented. So let's click on the tick to confirm and then hover over to discover the parts we want to get rid of. Click on them to select them, press delete on the keyboard, and that will prompt us to delete the parts. To join everything back together, we're going to click on Boolean. We'll leave the option as union, which means to add, and then all we need to do is to click our three parts, followed by the tick, and everything will be joined together. On the original part, we actually have a little corner cut out, so we're going to do that next. We can start a sketch on the surface of one of the prongs, then press U to use and trace two of the lines to snap to. We now use the line tool to draw the cutout, spin the camera around, and then apply some dimensions. These are on the inside, so they're hard to get exact, but hopefully they'll be close enough. Let's click the tick to close the sketch and then come up to extrude. It won't select the profile we just drew, and that's because it's still on surface mode. So let's put it back to solid, and then we can click our region, set the extrude to remove, and instead of blind, we'll set the end condition as up to vertex, and then click on the back of our opposite prong, cutting through perfectly. Another tick to finish the extrude, and we've only got one more feature left. On the inside of the duct, there's some little support fins that strengthen these prongs, so that's our last thing to model. On the real part, it looks like they're in line with this cutout, so I'm going to click on that surface, then sketch, and that means I'll automatically be drawing on that surface as the plane. However, because I'm drawing on the inside of the part, you can't actually see what you're doing. The solution to this is to do a temporary section view. So we come to the view cube, down to section view, we click a flat surface on the front, and then drag the arrow until it goes far enough to reveal the inside of the part. Now when we press N to spin the camera, we can actually see what we're drawing, and that's going to make a big difference. I need something to snap to, so I'm going to press U for use and click the outer edge of one of these prongs. It's impossible for me to get in and measure this support structure perfectly, so I'm just going to try and match it as closely as I can. I have an arc at the top, and then a straight line coming diagonally towards the rest of the prong, and then finally an arc at the base that looks like it blends in on a tangent. We can see here that the sketch that we're drawing extends inside the part, and in this case that's actually what we want. That way when we extrude the support fin, we know there's not going to be any gaps between the curvature on the inside and the fin. Obviously there's a fin on each side, so let's add a construction line down the middle and then immediately use the mirror tool to copy over everything we've just drawn as part of our sketch. And when we hit the tick, that completes our last sketch. We'll now come up to the extrude tool, select our two new regions, and visually to me they need to go towards the front, so I'll reverse the direction, and they look around 1 millimeter thick. Looking from top, that looks pretty symmetrical, so I'm guessing that my dimension is a pretty good guess. And as far as I am aware, I have now modeled everything that needs to be modeled. So let's turn off our section view by coming to the view cube and going to turn section off and admire the result of all of our effort. With the part modeled, it's time to print it, this time from resin. When exporting from Onshape, I made sure that the resolution was set to fine for maximum detail. The model was then imported into G2 Box and rotated in a position that I thought would give a good compromise between print time and the ability to add efficient support. My plan was to put it all on the underside of the part where you wouldn't really see it when everything was removed. On the medium preset, I applied Box's automatic supports from the platform, and this gave a result that I hoped would be viable. My only concerns were removing the internal support, but generally it snaps off pretty nicely, so fingers crossed. The print turned out great first go, so I went through the usual process of cleaning, removing that support material, and I was very pleased to find that it simply pulled away with a minimal amount of force. The trickiest, as expected, was the support on the inside, but I was able to pull it off without any tools, without damaging the little prongs. Finally, some time in the post-curing chamber, and then we can compare what we've designed to the initial part we were copying from. The overall size looks to be very close, with the length as well as the width matching nicely. And if we line up the undersides, the curvature seems to be pretty close as well, front to back as well as side to side. The prongs were the hardest part to measure, but it looks like at least they're in the ballpark. And in terms of the critical hose fitting, it looks like we might be spot on there. So I'll now be optimistically passing this part on to my brother-in-law. It's highly likely that a small tweak will be required to get this perfect, but the magic of 3D printing makes that really easy. Hopefully this custom part had enough elements to showcase the workflow required, and remember that workflow will translate over to other CAD programs in much the same way. Thank you so much for watching, and until next time, happy designing custom parts for 3D printing. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.